Hi everyone. So today I will be discussing the October 2021 Further Pure Mathematics paper 3. Question number 1, they say the curve C has equation y equal half r cos 2x and x limits are from 702 to 13. Using calculus, determine the exact length of the curve C, giving you answer in the form P root Q. Okay, so when it comes to the arc length, you have a specially formulated equation given in your textbook, right? It's given in the formula booklet as well. So arc length you have it in two formats, one in Cartesian form, the other one in parametric form. So this is the arc length equation that you find in Cartesian form. So root 1 plus dy by dx whole thing square. You have to integrate. So first, shall we find dy by dx? Okay, so apply the arc length. I had to first find dy by dx. Can I know how to differentiate y equals half r cos 2x? So what's the differentiation of cos 2x? Cos x? The cost differentiation, can you all tell me what's the cost differentiation? The differentiation of r cost. Yeah. R cos x differentiation is 1 over root x square minus 1. This is if it's r cos x. Okay, so when it's r cos 2x, you have to apply the chain rule where you replace x with 2x, and also at the end you have to keep you have to multiply with the differentiation of 2x. So let's get dy by dx equals half times r cos 2x differentiation 1 over root x is now taken as 2x. So 2x when you square it, it's going to be 4x square minus 1. You're not done with it yet. Chain rule, differentiate the 2x again into 2. So these differentiations are given in the formula book, right? Differentiation of r cos x is there in the formula book. So when you simplify, this becomes dy by dx, the half and 2 cancels. So you get 1 over root 4x square minus 1. Okay, so now it's time to input that in the arc length equation. So arc length equals integration square root 1 plus, so dy by dx square. So if you square it, you do realize that squaring of your whole function will remove the root in the denominator. Square of 1 is 1, right? So 1 over 4x square minus 1 with respect to x. And what about your x limit? Question they told you x is between 7 over 2 and 13. Okay, so now it's up to us to simplify this and integrate. So shall I take the common denominator? We can take 4x square minus 1 as the common denominator. So this is 1 over 1, which means the top one multiplies entirely with 4x square minus 1 plus 1 with respect to x. So I get here integration of root 4x square over 4x square minus 1 with respect to x. Okay, so then we can simplify this, the 4x square in the numerator, we can take it out as 2x over square root of 4x square minus 1 with respect to x. Okay, so now we come to this point. So how do we proceed further from here? How do we integrate? What's the next step in integrating? Yeah, so we use, so we have our integration rules which we learn in P3 integration rules, right? So which integration rule are you going to go with? Yeah. So sorry, this is the differentiation rule. Yeah. So integration rule. So as you can see, I will go with rule number. So this one, the last one, because there's a power in the numerator. Sorry, there's a power in the denominator. So we will go with the 11th rule. So however, to do the 11th rule, it's better to have your denominator. You have to bring the root 4x square minus 1 up, right? So when you bring it up, what happens? 2x times 4x square minus 1 to the power minus half. Okay, so I need to have the perfect f dash x outside here. Do I have the perfect f dash x of this fx? 4x square minus 1 is the fx, the power minus half is the n. So ignoring n, if you take the power, differentiation of fx, I need to have the perfect f dash x outside. What's the differentiation of 4x square minus 1? 8x. So the crucial element x is there. So we can input constants. We can't input x actually. We can't input any x term, but we can input constants. So to make 8x, what do I need? I just need to multiply by a 4 to make it 8x. So to cancel out, we'll put a 4 outside as 1 over 4. You know, you can input constants, right? Outside the integral sign. So I end up getting here 1 over 4 into integration of 8x times 4x square minus 1 to the power minus half with respect to x. So this is the perfect f dash x now. So time to integrate 1 over 4 and then go with the rule fx to the power n plus 1. 4x square minus 1 to the power n plus 1 minus half plus 1 is half. Divide by half. No, we don't need to put the plus c. We have the limits. Shall we first simplify? 1 over 4 divided by 1 over 2 is 1 over 2. And so we'll apply the limit to 4x square or root 4x square minus 1, right? Power half. The limits are from 7 over 2 to, so I just keep the half outside, okay? Keeping half outside, what do I get here? Root 4 into 13 square minus 1. How much is 4 into 13 square? 4 into 13 square is 169 minus 1. Subtracting square root of 4 into 49 over 4, 7 over 2 square minus 1. Can I know these answers? Half into, how much is this? 15 root 3. How much is this? 4 root 3. Oh yeah, the 4 cancels. So 49 minus 1 root 48. 4 root 3. So 15 minus 4 is 11 root 3. So half into 11 root 3, which is 11 over 2 root 3. So this is the answer. Okay, this is clear. Okay, so moving on to question number 2, they say given that cos y equal x and y is less than 0. Okay, y is less than 0. Use the definition of cos y in terms of exponential functions to prove that y equal ln x minus root x square minus 1. So I think you have done this proof in your textbook, but the proof you have done is for ln x plus root x square minus 1. Okay, so the one that we use in the book. So now you have to prove if your y values are negative, then the correct equation to use for negative y values would be ln x minus root x square minus 1. Okay, so let's see what they're talking about. The first thing is they ask you to use the definition of cos y in terms of exponential functions. Okay. How do we write the exponential function? So cos y equals, cos y is equal to x. So yeah, so let's write, let me write again, x is cos y. What is the definition of cos x? Yeah, so the definition you learned for cos x is e to the power x plus e to the power minus x whole thing divided by 2. So cos y is e to the power y plus e to the power minus y divided by 2. Are you with me? Okay, and now your task is to make y the subject, right? You have to find y. Okay, how do we find y? So I get here 2x equals e to the power y plus e to the power minus y. Okay, then what's the next step? You have a negative e to the power y, so it's a 1 over e to the power y, right? So we will multiply the entire equation with a e to the power y to make it positive power. So here I get 2x times e to the power y. Here ey into ey is e to the power 2y plus e to the power minus y into e to the power plus y is e to the power 0, which means it's simply 1. So what do we have here? We have a quadratic equation e to the power 2y minus 2x e to the power y plus 1. Okay, so this is the equation that we have for, this is the quadratic equation. Now, you have to solve it. So, you can see here e to the power 2y is like your a square. You see, this is like, so you are quite capable of seeing this now 2xa plus 1. Okay, I'm not going to go with this directly. Let's write the answer. We'll use the quadratic formula. So, and we will solve the value for whom? We will solve the value for e to the power y, isn't it? So, e to the power y equals minus b. What are your ABC values? A is the x square coefficient, e to the power 2y is your x square, so the a coefficient is 1. The b coefficient, so this is like a square. This is a. So then the coefficient of this a is minus 2x. and c is plus 1. Okay, so e to the power 2y equal minus b, so minus 2x plus or minus square root b square minus 2x square, b square minus 4 into a is 1 into c is 1. Divide by 2a, 2 times 1. Okay, so what do we get here? E to the power y equals 2x plus or minus this is 4x square minus 4 divided by 2. Okay, so we can simplify here. E to the power y equals 2x plus or minus the 4. You can bring it out of the root as a 2, and inside the root you get x square minus 1 divided by 2. 2 is common to everyone. You can take a 2 out and cancel. So 2 cancels and you get e to the power y equals x plus or minus root x square minus 1. Okay, so you come to this point, and then to make y the subject, you apply ln to both the sides, right? So e to the power y, the y comes forward, y times ln e is 1. So we get ln x plus or minus root x square minus 1. Okay, so now we come to this point. So now you have to give your final phrase here of how you are going to choose the ln x minus root x square minus 1 over ln x plus root x square minus 1. Okay, so how do we give this? How do we choose? So you have two options. Y equals ln x plus root x square minus 1, or you have y equal ln x minus root x square minus 1. Okay, how do you defend your answer? How do you eliminate this answer and defend this answer? They have told you y values should be negative. So now you have to select out of these two equations which equation is capable of generating negative answers for y. Okay, so how do we justify? Now you can't just look at this and say this is small, it gives no. You have to give a logical statement here. So what's the logical statement? The first thing is, what do we know about x? Do we know what are the values that we can use for x? Can I use every single value for x, or is there a certain range of x values that I should use here? Now, who is x equal to? They haven't told you anything about x, but we do know x is equal to cos y. And if you remember the cos graph, do you remember the cos graph? Cos graph, ex plus e minus x, you take the median of those. So it was a graph that came like this, right? Can you remember? So you didn't remember. And then the minimum point of that graph was 1. So if you draw the cos y graph, this is the cos y graph. Minimum point of cos y graph is 1, which means what are your x values? So cos y graph values are 1 or higher. Are you with me? Which means x values are more than 1. Okay. So since your x values are more than, we will be using x values more than 1. Okay. So you can say here, since x values are positive, not positive, since x values are greater than 1, right? Okay, so what can you say about the first answer? Ln x plus root x square minus 1 is definitely a what figure? It's definitely positive, right? So you can see inside this one, ln x plus root x square minus 1 is definitely positive for x greater than 1. So then does this work? No. Okay, then what about the other one? So what about ln x minus root x square minus 1? When your x values are greater than 1, okay, so you can type and see here x plus root x square minus 1, you are always going to get a positive value. You are going to get a value bigger than 1. X plus root x square minus 1 will always be larger. Now you need to remember in logarithms, ln, you don't have ln of negative figures, right? Ln negative is math error. So if you get ln values, the critical point is values of ln below 1 and more than 1. Okay, there are no negative values for ln. So below 1, so 0 point. So if you take a ln value of 0.5, you know, you should realize that a logarithm graph, or if you draw the lnx graph, this is how the lnx graph looks like, right? Okay, so you can see for x values less than 1, you have negative answers for the logarithm. While for x value is bigger than 1, if the inside of the logarithm is larger than 1, you get positive answers. So right now I want my y to be negative, which means I want this logarithm to give me a negative answer. If the logarithm gives me a negative answer, it means the part inside the logarithm should be less than 1. The part inside the logarithm must be less than 1, more than 0. Are you with me? So values of inside the logarithm which are more than 0 and less than 1 are the values that can generate negative. Okay. Okay. So then what do you say here? What can we say about x minus root x square minus 1? X minus root x square minus 1, what can we say? This is? Yeah, check values. Okay, so for x value is greater than 1, you can try it and see in the cal. X minus root x square minus 1 answers are going to be more than 0 but less than 1. Okay, these values are going to be more than 0 and less than 1. Okay, so these values are less than 1, which means what? Which means if you take the logarithm of a number less than 1, it's going to give you a negative answer. Okay, so you can say here, since y is less than 0, they have told you y should be less than 0. Since y is less than 0, ln x minus root x square minus 1. Okay, ln x minus root x square minus 1 is giving answers less than 0 for x greater than 1. Okay, so this means your answer should be, so this means your answer for y should be ln x minus root x square minus 1. So we can erase these parts. Okay, so you need to realize here x minus root x square minus 1 is a value less than 1. The inside part. So logarithm of a value less than 1 more than 0 is a negative answer. Okay. Okay, is this clear? Question number 3. The ellipse E has equation x square over 64 plus y square over 36 equal 1. The line L is the normal to ellipse at the point P equal 8 cos theta 6 sin theta. Using calculus, show that an equation for L is this. Okay. So how do we get to show that? First thing is to get the gradient, right? So x square over 64 plus y square over 36 equals 1. When you differentiate, 1 over 64 times x square differentiation is 2x plus 1 over 36 times 2y square. So this is 2y dy by dx equals 0. So when you make 2y dy 2y over 36 dy by dx equals minus 2x over 64. So I can cancel out 2 here. And what do we get then? Dy by dx equals minus 36 over 64 x over y. Can you see? Can I know the simplification of minus 36 over 64? Minus 9 over 16 x over y. And then we need to substitute the point 8 cos theta 6 sin theta. Substitute and get the gradient of the tangent. Minus 9 over 16 x is 8 cos theta divided by 6 sin theta, right? How much is it? 9 over 16 into 8 over 6 is how much? Minus 70. It simplifies. Minus 3 over 4 cos theta over sin theta. Yeah, we'll keep it as cos over sin because it shows that also has cos over sin. Okay, so this is the gradient of the tangent. Dy by dx is the gradient of the tangent. Get the gradient of the normal. Gradient of the normal, switch the sign and reciprocal. 4 over 3 sine over cos. And let's get the equation of the normal. So equation of normal, y minus y1 equal gradient x minus x1. So y minus y1 is 6 sine theta, gradient is 4 over 3 sine theta over cos theta. X minus x1 is 8 cos theta. So now to show that is all in terms of x and y, I'll take the 3 cos theta to the other side. 3 cos theta into y is 3y cos theta. 3 cos theta into 6 sine theta is 18 sine theta cos theta. Here we will open the bracket with 4 sine theta. 4 sine theta into x is 4x sine theta. 4 sine theta into 8 cos theta minus 4 times 8, 32 sine theta cos theta. Yeah, in the show that they've taken y cos theta to the other side and the 32 is taken over here. So I'll bring 32 here. It's over here. So I get here plus 32 sine theta cos theta minus 18 sine theta cos theta equals 4x sine theta minus 3y cos theta, which is 14 sine theta cos theta equals 4x sine theta minus 3y cos theta. This is the show that for part A, the equation of the normal, the equation of the normal to the curve. Then we'll move into the next part. They say the line L meets the x-axis at the point A and meets the y-axis at the point B. Okay, so when you meet x-axis, y0. So input y as 0 and you get 4x sine theta minus y0 equals 14 sine theta cos theta. So when you make x a subject, you get 4. The sine theta will cancel out, right? 14 cos theta over 4, which is 7 over 2 cos theta. So, and then also when you meet the line L meets the x-axis at the point A. So point A coordinate is 7 over 2 cos theta comma 0. And then say it also meets the y-axis at B. So meeting when you meet y-axis, x is equal to 0. So you write 4x sine theta is 0 in this equation minus 3y cos theta equals to 14 sine theta cos theta. So this gives me y equals cos theta cancels minus 14 over 3 sine theta, which gives the coordinate of B where you cut y-axis, x is 0 minus 14 over 3 sine theta. Is this clear? And then what do they say? They say the point M is the midpoint of AB. So midpoint M. So how do you get it? You add the x coordinates 7 over 2 cos theta plus 0 and divide by 2. Add the 2 y coordinates 0 and minus 14 over 3 sine theta and divide by 2. So what do we get here? 7 over 4 cos theta 14 over 3 divided by 2 minus 3 sine theta. So we get here x equals, so now we need to get the locus, right? They ask you determine a Cartesian equation for the locus of M as theta varies, giving you answer in the form ax square plus by square equals c. So you have to get the locus of this. So the x coordinate of the midpoint is 7 over 4 cos theta. The y coordinate is minus 7 over 3 sine theta. So cos theta is 4x over 7. The y sine theta is minus 3y over 7. And then how do we eliminate theta and get x and y together? By using the equation sine square theta plus cos square theta equal 1. Sine square is minus 3y over 7 square, which is 9y square over 49. Cos square is 16x square over 49 equals 1. So they wanted to get the equation ax square plus by square equals c, where a, b, c are integers. So multiply everyone by 49. 9y square plus 16x square equals 49, which is the show that. This is your show that. Okay, is this clear? Okay, so in October 2021, question number 4, this is the matrix question, right? So matrix M is given by 2k minus 2, 0, 3, 1, minus 1, 2k. Show the determinant M is 5k minus 10. How do you get the determinant? So you can see I have already used the plus minus plus. Let's get the determinant M. So write the plus 2, remove the row and column with 2, and you get 3, 1, 2k, right? And then it's minus 0, and I'm not going to be bothering. We don't need to write the remaining elements for 0, right? Because you multiply with 0, it's all, yeah, then you have 0. And then minus 1, remove the row and column, it's k minus 2, 3, 1. Are you with me? 2 times multiply 3 into k is 3k, minus 1 times 2 is 2. 0 is not necessary, minus 1 times k into 1 is k, minus 2 into 3 is minus 6. So I get here 2 times 3k minus 2 minus 1 times k plus 6. Are you with me? Open the bracket, 6k minus 4 minus k minus 6. So this becomes 6k minus k is 5k minus 4 minus 6 is minus 10. Are you with me? 5k minus 10. Yeah, so that's the show that. Can you see the determinant? For 2 marks. Then part B, they want to find M inverse. Okay, so this is a little bit of a long technique, right? Do you remember to find M inverse? You have to find the matrix of minus, matrix of cofactors. Okay, so shall we start? Okay, what's the first thing we should do? Okay, to find M inverse, what's the first thing you all did? First, you all found one. Which matrix? The matrix of minus, right? Yeah, so how does that work? So let's get the minor matrix. How do we get the minor matrix? In minor matrix, what you do is take each element, remove the row and column of that element, and write the remaining element. So if you take 2 here, remove the row and column with 2, what's remaining? 3, 1, 2k. Are you with me? The next element, you remove the row and column with the 0 here. So you get k minus 2, 2k. The next one, remove the row and column with minus 1, you get k minus 2, 3, 1. The next one, remove the row and column with k, you get 0, 1, minus 1k. The next one, remove the row and column with 3, remove the row and column with 3, you get 2 minus 2, minus 1k. Are you with me? The next one, remove the row and column with 2, 2 minus 2, 0, 1. The last one, remove the row and column with minus 2, you get 0, 3, minus 1, 2. Next one, you remove the row and column with 1. And then you get 2k, minus 1, 2. And the last one, you remove the row and column with k, so you get 2k, 0, 3. Okay, so this is the matrix of minus. Shall we simplify? So how does it simplify? So you get here 3k minus 2, right? The first element. The next element, k into k square minus 2 into minus 3 is minus 4. Minus 3 is plus 4. Is that okay? The next one, k into 1 is k, minus 2 into 3 minus 6. So minus is again plus 6. Are you following me? Next one, 0 into k is 0, minus 1 into minus 1 is minus 1, minus 1 is plus 1. 2 into k is 2k, minus 2 into minus 1 is plus 2. So plus minus is minus. Is that okay? The last one, 2 into 1 is 2, minus 2 into 0 is 0. Next one, 0 into 2 is 0, minus 3 into minus 1 is minus 3, along with this 3. It's plus 3. 2 times 2, 4 minus k into minus 1, that's going to be plus k. 2 times 3 is 6, k into 0 is 0. So you get this. Are you okay with it? Is this okay? This is the matrix of minus. Is that okay? Okay, so after the matrix of minus, get the matrix of cofactors. How do you get the matrix of cofactors? By putting the alternating sign rule, isn't it? Are you with me? Alternating sign rule, how does it work? Yeah, 3k minus 2, k square plus 4. I'll write the thing again. K plus 6, this is 1. 2k minus 2, 2, 3, 4 plus k and 6. This is what you get, the matrix of minus. So in matrix of cofactors, you just give a alternating sign. First element is plus, second element you give a minus. This is a plus. This is minus, this is plus. This is minus, plus, minus. Plus, make sure when you're giving the minus that there is definitely a bracket around it, okay? So this is the matrix of minus, and then what's the next thing you do? The cofactor matrix, you must take it you must take the transpose of the cofactor matrix. So what happens then? Take the transpose. These are the steps, right? These are the steps to produce the inverse matrix. 3k minus 2 minus 1 plus 3 comes, then minus k square minus 4. Shall I open the bracket? This is 2k minus 2. The row and columns exchange. The second row becomes the second column, minus 4 minus k. This is k plus 6. This is minus 2. This is plus 6. Is that okay? So this is the matrix of cofactors. And then, yeah, now the last step is to get the inverse matrix. Inverse matrix is 1 over det m into matrix of cofactors, isn't it? So what was the determinant then? 1 over 5k minus 10 cofactor matrix. 3k 3k plus 2 or minus 2? 3k minus 2, right? 3k minus 2 here, right? 3k minus 2 minus k square minus 4 k plus 6 minus 1 2k minus 2 minus 2k minus 2 and then minus 2, yeah, and then 3 minus 4 minus k and 6. Are you okay with it? This is your inverse matrix. Is this clear? Okay, moving on to the last part. They say the point O 0 0 0, the point A 4 minus 8 3 and B minus 2 5 minus 4 and C 4 minus 6 8 are the vertices of a tetrahedron T. So they have given you a tetrahedron. Now they're saying the transformation represented by M here transforms T to a tetrahedron with volume 50. Do you get what's going on here? The transformation given by the coordinates of tetrahedron T are going to be transformed by matrix M, and then when you're transforming, you will end up getting a new set of coordinates. The new set of coordinates are having what? The new set of coordinates make up a new tetrahedron, and that tetrahedron has a volume of what? 50. Are you with me? Determine the possible values of K. So first things first, do you remember how to find the volume of a tetrahedron? So let me just draw this diagram here. Do you remember? This was O, if this is A, if this is B, and if this is C. How do you get the volume of a tetrahedron? Volume of a tetrahedron is 1/6 of. You can write here, so it doesn't matter, like you can, it doesn't matter how the order of the coordinates are. Okay. So we normally write OA dot OB cross OC, right? Do you remember? A dot B cross C, the triple scalar product. The triple scalar product gives you A dot B cross C gives you a volume of a parallel pipe. So these are theories in your F3 book. Okay, so the triple scalar product gives you the volume of a tetrahedron if you use 1/6 of A dot B cross C. Okay, 1/6 of A dot B cross C gives you the volume of a tetrahedron. So now the thing is, they have given you the volume of which tetrahedron, the original one or the transformed one? They have given you the volume of the transformed one. So what do you need to do here? Now, can I use the ABC original coordinates? No, I have to get the new coordinates. How do I get the new coordinates? They have given, you have the transformation matrix, right? And you have the object coordinates. Can't you find the image coordinates? So then the point 0, 0, 0, do you think it's going to move? Point 0, 0, 0 will not move. These are linear transformations. Point 0, 0, 0 will not move. So you have to get the new A, new B, and new C. How do you find it? New coordinates. How do you get the new coordinate? Transformation matrix into what? Into object coordinate. Transformation matrix into object coordinate. Can you all quickly get it in matrix A? The coordinate A is 4, -8, and 3. Multiply, what do you get? So you know here the entire row multiplies with this, right? To give the first element. So what is it? 2 into 4 is 8. 0 into 8 is 0. -1 into 3 is -3. That's the first x value. Y value, 4 into k is 4k. 3 into -8 is -24. 2 into 3 is 6. Are you with me? Last one, -2 into 4 is -8. 1 into -8 is -8. K into 3 is 3k. So this gives you what? 8 minus 3 is 5. 4k minus 24 plus 6 is how much? -18. -8 minus 8 is -16 plus 3k. So this is the A, the new A coordinate, A dash. Let's get the new coordinate B. 2, 0, -1, k, 3, 2, -2, 1, k. The B coordinate is -2, 5, -4. So when you multiply, what do you get? 2 into -2, -4, 0 into 5, that's a 0. -1 into -4 is +4. Agreed? Next one, k into -2 is -2k. 3 into 5 is 15. 2 into -4 is -8. -2 into -2 is +4. Plus 1 into 5 is 5. K into -4 is -4k. -4 plus 4 is 0. -2k. 15 minus 8 is how much? +7. 4 plus 5 is 9 -4k. So this is the new coordinate B. Agreed? Get the new coordinate C as well. 2, 0, -1, k, 3, 2, -2, 1, k. Multiply with the coordinate C. 4 minus 6, 8. Multiply, what's the answer? 8. 0 into -6 is 0. -1 into 8 is -8. 4k. 3 times -6 is -18. 2 times 8 is 16. -2 into 4 is -8. -6 plus 8k. So when you add, what do you get? 0. 4k minus 2 minus 14 plus 8k. So I have the new coordinate ABC. I have the new coordinates of ABC. Okay, so now it's time to use the volume equation A dot B cross C. You remember what's the way to get A dot B cross C? This is again a 3 by 3 matrix, right? The determinant of a 3 by 3 matrix where the first row gives the A coordinate, second row gives the B coordinate, third row gives the C coordinate. We'll give you the A dot B cross C. You get the value, the scalar triple product. Are you with me? And then afterwards, you have to get 1/6 of the modulus of that answer. Okay, so let's get OA dot OB cross OC. What do you have to do? The scalar triple product. So you use the determinant of a 3 by 3 matrix. Use the elements 5, 4k minus 18. Input the values 5, 4k minus 18. Should I write a little bit down? 5, 4k minus 18. What's the third element in A? Minus 16 plus 3k. The second row will have the B element, which is 0, minus 2k plus 7, and 9 minus 4k. The third row has 0, 4k minus 2 minus 14 plus 8k. So all you have to do is get the scalar triple product, get the determinant that gives you the scalar triple product. So we get here what? 5 times, remove the row and column, minus 2k plus 7, 4k minus 2, 9 minus 4k minus 14 plus 8k. Next one, minus 4k minus 18, remove the row and column. So it's 0, 0, 9 minus 4k minus 14 plus 8k. Next one, plus minus 16 plus 3. I'm just getting the determinant here, okay? Remove the row and column, 0, 0, minus 2k plus 7, 4k minus 2. In the moment you write these two matrices, you can see the determinant will, it's giving you 0, right? When you multiply, can you see? So only the first one needs, you don't need to suffer with everyone. So when you multiply, you get minus 2k plus 7 times minus 14 plus 8k minus 4k minus 2 with 9 minus 4k. Are you with me? The others, I think you can see they will all become 0. Can you see why are they becoming 0? Because when you take the determinant, it becomes a 0. 0 into this is 0, 0 into this is 0, and 4k minus 18 times 0 is 0. Likewise, both of them, because of this multiplying with the 0, the whole thing becomes 0. Are you with me? So now simplify and get the determinant. Simplify and get the answer here. Minus 2k into minus 14 is plus 28k, right? Minus 2k into minus 8k is minus 16k square. 7 times minus 14 is minus 98. 7 into 8 is plus 56k. Here when you're opening the bracket, be careful, there's a minus sign outside. 4k into 9 is 36k. Opening the second bracket, 4k into minus 4k minus 16k square. Then minus 2 into 9 is minus 18, minus 2 into plus minus 4k is plus 8k. So here 28k plus 56k, can you all add? How much is it? 28 plus 56 is 84k minus 16k square minus 98. Open the bracket here. If I open, can you all add 36k plus 8k? Is how much? 36k plus 8k is. So with the minus sign, it becomes minus 44k. Minus minus plus 16k square minus minus plus 18. So when you simplify, I think we can see the minus 16k square plus 16k square cancels out. What do you get here? 84k minus 44k is 40k, right? 84 minus 44 is 40. Minus 98 plus 18 is minus 80. So multiply with 5. 5 times 40 is 200k. 5 times 8 is 4. Is that okay? 200k minus 400. So this is what? This is what you get for the A dot B cross C. Okay, so then to get the volume of the tetrahedron is 1/6 of modulus A dot B cross C. Volume was given as 50, right? A is A dot B cross C, you get 200k minus 400. So when you're solving, 50 times 6 is how much? 300 equal modulus 200k minus 400. So what do you do to solve it? Take the plus part of the modulus and minus part of the modulus separately to get the k values. Okay, so then what do you do here? 300 equals to positive 200k minus 400. Or 300 equals, take the negative of this, right? Minus 200 plus 400. Are you with me? 300 plus 400 is 700 equals 200k. How much is k? K is 7 over 2. k is 7 over 2. The other one, I'll take the minus 200k to this side as plus 200k, 400 minus 300. So I get 200k equals 400 minus 300 is 100. And I get k equals 100 over 200, which is half. Is that okay? Okay, is this clear? Are you clear with this? Are there any questions? Okay, is this okay? Okay, so now I'm moving on to question number 5 in the F3 October 2021 paper. They say the skew lines L1 and L2 have equation L1 equal R I plus 2j minus 5k plus lambda times 5i plus j. Line 2 has equation R equal to 2i minus 4j plus 4k plus mu times 8i minus 2j plus 3k. My first question to you is, what do you mean by skew lines? Skew lines are three-dimensional lines that do not intersect. They do not intersect. They are neither are they parallel. So two lines that are not parallel, then they do not intersect, especially. They say you determine a vector that is perpendicular to both line 1 and line 2. So what do we learn in the vector lesson? The whole, the very beginning of the vector lesson, we learn a technique to produce a vector that is perpendicular to two given vector, and that is called the cross product. The cross product will produce a vector perpendicular to the two given vectors. So A cross B is a vector perpendicular to both A and B. So likewise, if you want a vector that is perpendicular to both line 1 and line 2, what do you have to get the cross product of? You have to get the cross product of the two direction vectors of your lines. If you get the cross product of the two direction vector of the two lines, you will get a vector perpendicular to both line 1 and line 2. Are you with me? So let's get the cross product. So I, j, k, and the first one, the direction vector of the first line is 5i, 1j, 0k. And the other one, 8i minus 2j, 3k. Plus minus plus, and get the let's get the matrix. So let's get the answer. So here I get, when I remove the row and column with I, it's 1 minus 2, 0, 3 minus j times 5, 8, 0, 3 plus k times 5, 8, 1 minus 2. Are you with me? So then I get here I times 1 into 3 is 3 minus 2 into 0 is 0 minus j times 5 times 3, 15 minus 8 times 0 is 0 plus k times 5 times minus 2 minus 10 minus 8 into 1 is 8. So when I simplify, I get here 3i minus 15j minus 18k. Okay. Okay, so I found the vector perpendicular to both line 1 and line 2. You'll agree with this. I think you can see that there's a multiple here. So when it comes to, even if you remove the multiple and write, it's completely fine. Okay, because the reason is we are determining a vector that is, we kind of like get a direction vector. So any multiple of this, or even removing the multiple of 3 and writing the answer is perfectly fine, or you could just leave your answer in this manner. Okay. So in part B, they say determine an equation of the plane parallel to line 1 that contains line 2 in the form R equal A plus SB plus TC. So this is the vector form of a plane. So you do remember A is what? What does A stand for? A is a position vector on the plane. Okay. And what are B and C? B and C are two direction vectors on the plane. Okay. Okay. B and C are two direction vectors on the plane. Okay, so the first thing is they tell you here that line 1, they say the equation, determine equation of the plane parallel to line 1. Okay, so the plane is parallel to line 1 and it contains line 2, which means what? Your plane directly contains line 2 on top of it, and it is parallel to line 1. Line 1 doesn't lie on top of the plane 2, on top of this plane. But line 2 is directly on top of it, like it goes on that plane. So they are asking you to get the equation of the plane. How do we get the equation? So you need to determine here what are your A, B, and C values. Okay, what can I use for A? A is supposed to be a position vector on the plane. What can I use for the position vector on the plane? Like L2 is a line. Like how can I use the line to equation to actually get a coordinate on the plane? You do realize when it comes to a line, it follows the format R equal A plus lambda B, right? Yeah, what does A represent? A represents a position vector on the line, while B represents the direction vector of the line. So now, if A is a position vector of the line, that means we have a coordinate that lies on top of our line. Okay, and I mean basically, I mean you could get actually any coordinate on top of line too by actually inputting values from mu also. Actually, that is also one way. So actually, this point A. So for example, 2y minus 4j plus 4k, it immediately gives you a coordinate of a point on the line. Since your line is on the plane, it will automatically be a line that be a position vector on the plane also. Do you get what I'm trying to say? A position vector on the line will automatically become a position vector on the plane because the line is on top of the plane. The line is lying on the plane. So any position vector on the line is automatically a position vector on the plane. Okay, so this is directly a position vector on the plane. Actually, you could generate as many position vectors as you want by inputting values from you. Okay, so anyway, we'll not go in that part. We'll use the direct position vector. Okay, so then for A, I will use 2y minus 4j plus 4k. Are you with me? And then for B and C, what do I use? So B and C are supposed to be direction vectors, two direction vectors on the plane. Can you all tell me two direction vectors on the plane? Yeah, what are the two direction vectors on this plane? So for B, a direction vector on the plane, I can use the direction of line 2 because line 2 is on the plane. We could use the direction of line 2 to represent the direction vector on the plane. 8 minus 2, 3. And for C, I want another different direction vector on this plane, another direction vector on the plane. So for that, since there's a line 1 is parallel to the plane, I can go with the line 1 direction. Okay, so because the line 1 is parallel to the plane, the line 1 direction vector is 5y, 1j, 0k. Okay. So it's just one mark. Input the value r equals a 2 minus 4 plus s is the parameter, b is 8 minus 2 3 plus t times c is 510. Do you agree? So they want you to determine the equation of the plane parallel to line 1 that contains line 2 in this form, r equal a plus sb plus tc, just one mark. And Roman number 2, they want you to give it in the format r dot n equal p. How do you convert to r dot n equal p? So in this case, how do you convert to r dot n equal p? So r dot n, here p stands for what? R dot n equals a dot n. How do we normally generate a vector perpendicular to a given plane? How do we generate a vector perpendicular to a given plane? Yeah. So we have to get the cross product of the, now you can see we have two direction vectors on top of the plane, right? 8 minus 2, 3, 8 minus 2, 3 is a direction vector on the plane. 510 is also a direction vector on the plane, right? So if you take the cross product of these two vectors, you should get a vector perpendicular to both of them, isn't it? So then n is equal to the cross product of B and C, B cross C. So B is 8 minus 2, 3. You need to get the cross product with 510. Didn't we actually find this earlier? In part A. See, we got in part A, we got the cross product of 510 with 8 minus 2, 3. Can you see? And we already have the answer. 3i minus 15j minus 18k. I minus 15j minus 18k. Do you agree with me? Okay, so then we have the vector n. So now time to get the a dot n value. So what's our p value? So R dot n equal A dot n. A dot n is the P value. Okay, so P is A dot n. Get the A dot n value. A is the position vector on the plane, which is 2 minus 4, 4. Dot product with n. 3 minus 15 minus 18. Get the cross product and get the dot product. So you have to multiply 2 times 3, 6. Adding with minus 4 into minus 15 is how much? 60. And then adding with 4 times minus 18, minus 72. So add everything together. How much do we get? Minus 6. Okay. So now you can give it in the format R dot n equal P. So R dot n is 3i minus 15j minus 18k equals minus 6. Okay, you could even simplify the whole thing by dividing by a 3 and give an equivalent answer. So that's also correct. Okay. Yeah, so in part A, there's a concern saying that we used C cross B, right? So in part A, we use C cross B, right? So actually we could use here instead of, yeah, so this is what I have used here is C cross B. Okay, so it doesn't matter actually. B cross C would be a negative answer, a negative multiple of this. So it will not make an impact, just be a multiple. Okay. So we'll use the help of the earlier part to do the sum. That would make, that would save us a lot of time. Okay. Okay, so in part C, they say determine the shortest distance between line 1 and line 2. Give you an answer in simplest form. So line 1 and line 2 are two skew lines. So you have learned in vectors in F3 the shortest distance between two skew lines. So this is a theory you learn in the F3 book. The shortest distance between two skew lines R equal A plus lambda B, R equal C plus mu D is can you see A minus C dot B cross D divided by modulus B cross D. Okay. So I think B cross D we already have, right? Because line 1 and line 2, we already have the direction vector cross product. Am I correct? The only thing I have to do is to get A minus C. Shall we get A minus C? So what was A? Can you all tell me the line 1 equation again? Line 1 equation is 1, 2, 1, 2 minus 5 plus lambda times 5, 1, 0. And then line 2, 2 minus 4, 4 plus mu times 8 minus 2, 3. Okay, so then we can see our A, B, C, D values. This is A, this is B, this is C, this is D. A minus C is 1, 2 minus 5 minus C is 2 minus 4, 4. So A minus C is 1 minus 2 is minus 1. 2 minus minus 4 is 6. Minus 5 minus 4 is minus 9. Okay. Okay. So then, yeah. So let's get the dot product A minus C dot B cross C. So A minus C dot B cross D. A minus C is minus 1, 6 minus 9. B cross D is the dot product of the two direction vectors. Okay, which is 3 minus 15 minus 18. Okay. Three minus 15. The answer is 1 into minus 1 into 3 is minus 3 plus 6 times minus 15 is, yeah, quickly, minus 90 plus 9 times 18 is 164 when you add everything. How much? 162. Sorry, no. This should be 162. Yeah. This is 69. Okay. And then what about the modulus B cross D? So you have to get the magnitude of the b cross d vector, which is 3 square minus 15 square minus 18 square square root. Okay, so now let's get the shortest distance. So you have a minus c dot b cross d, which is 69, divide by 3 root 62. Can you all simplify? How much does it give? 23 root 62, rationalizing over 62. So this is the shortest distance between your two lines. Okay, is this clear? This is the answer for part C. Okay, so question number 6, they say they have given you IN. So this is the moment you look at this question, you know it's the reducing the reduction formula question, right? Okay, so they have given you the integration of x to the power n cos x to the power 2. The power 2 only belongs to the x dx, and you have to prove that for n value is greater than or equal 5, your IN is equal to this expression. Okay. Now, the problem here is the biggest problem that you have here is how do we proceed with the integration. Okay, normally when you have two functions, the first thing that comes into our mind is, okay, we'll try to do integration by parts. But the biggest problem that we have here is we have a cos x to the power 2 and there's x to the power n. So because you can see the n powers are decreasing, we definitely realize that n x to the power n, or I mean this particular term it has to be the term that we differentiate. It has to be the u. Okay, then how do we integrate a cos x to the power 2? Because you know when you have inside a quadratic term, if you have just cos x, yes, we know how to integrate. But if it's a cos 2x, we know how to integrate. But if it's a cos, the x has a power, then we cannot use the general rules of integration, right? So to do this, what I have done here is, you can see on top, I've broken it down. Can you see x to the power n? I've broken it down as x to the power n minus 1 times x into cos x to the power 2. Okay, so I've broken down the x to the power n. And then what we do here is x to the power n minus 1 can be our u. And then the v dash is the x times cos x to the power 2, the dv by dx. Okay, so look, how do we integrate? How do we integrate x times cos x to the power 2? So I have written here the function that I'm choosing to differentiate. So you do realize that integration is the reverse of differentiation. So if you can find the function that you differentiated to obtain the answer, then you know integration is the reverse of that. So for example, you can see here, to get a cos, I can guess that I need to start off with a sine. So to get, because it's cos x square here, the x to the power 2, I decided to start to test my differentiation with sine x to the power 2. Because you know in differentiation, we can go ahead with any type of differentiation. So sine x to the power 2, when I differentiate, sine differentiation is cos x to the power 2, and then into you differentiate the x square function. X square differentiation is 2x. So you can see here, I'm creating the x cos x to the power 2. I have the x cos x to the power 2 now, but I am having an extra term 2 here. So to remove that term 2, you can take half of both the sides. Are you with me? So this means if you differentiate half sine x to the power 2, differential is x cos x to the power 2, which means integration of x cos x to the power 2 is half sine x square. Okay, so that means this is the v dash, or the dv by dx. Okay, so I'm about to use the product. I'm about to use integration by parts. uv dash integration is uv minus integration vu dash. Okay, here u dash is the dv by dx. Okay, here u dash is the du by dx. Okay, so then we'll write down the term. So you can see I have written here v dash, or the term that I'm integrating is x cos x to the power 2. When we integrate, I get half the sine x to the power 2. And then u is x to the power n minus 1, which means u dash is differentiate n minus 1 times x to the power n minus 2. Let's input the values now. 0 to root pi over 2. Okay. So I just rewrote the whole thing again. Shall we substitute? This is the u. This is the dv by dx or the u v dash. So let's integrate. When you integrate, what do you get? uv. So it's uv minus vu dash. So u is xn minus 1. V is half sine x to the power 2. uv minus integration v is half sine x to the power 2 u dash. U dash is n minus 1 x to the power n minus 2. Half x to the power n minus 1 sine x square. Okay. Yeah, we can substitute the limits to this part actually. That would make our life easier. Okay, and then this guy I can take the half out, and I'm getting again half n minus 1 out, and I'm getting here x to the power n minus 2 into sine x to the power 2 dx. So now we can again use a similar approach. Now you can see I've come to this point, which means again we have to do integration by parts. I had to again do integration by parts. For this part, shall we substitute the limits? Does it come easily? What happens when you substitute root pi over 2? So this, I think basically, yeah, so then I get here half x is root pi over 2 to the power n minus 1, right? To the power n minus 1, and then sine x square means it's directly pi over 2. Minus the other one, I think it's when you put x as 0, it's directly 0, so we don't need to go ahead with that. Okay, minus half times n minus 1. Now we need to deal with the integration of x n minus 2 sine x to the power 2. So I will be using a similar approach, right? So what's a similar approach? We need to break it up. X n minus 2, I'll break it up because to differentiate, to integrate sine x square, I need a sine term. So x n minus 2, I'll break it up as x to the power n minus 3 into x. Okay. Right, so then let's take, this will be my u dash, sorry, u. The u term, the term that you differentiate, and this is the v dash or the dv by dx. So let's see how to differentiate. How do we create sine x square? I mean, how do I create sine x square? By now, you know, I want to integrate x sine x square. But since we don't have a direct rule to integrate x sine x square, we start off by thinking, okay, what can I differentiate to get x sine x square? In that case, if you know what you differentiate to get x sine x square, that term integrated will give you x sine x square. Okay, so basically because it's a sine function, you know, definitely sine comes when you differentiate a cos. So let's try to guess the term that we differentiated. So I realize I am differentiating a cos x square, and I have a feeling there's a half involved here as well. The earlier one also involved a half. So let's differentiate. When you differentiate, half stays. Cos differentiation is minus sine x to the power 2 into 2x. So this time you can see the half and 2 cancel. That problem is there, but we have minus x times sine x to the power 2. So in this time, you can see I'm having extra negative sign. Okay, so how do I get rid of that? Yeah, we can multiply with a minus outside both the sides. So what does that tell you? So basically, x sine x to the power 2, this is the differentiated side, right? This is the differentiated side. So if I try to go in the integrated side, then integration of x sine x is minus half. Okay, minus half cos x square. Okay, then I think we are ready to integrate now, right? So if v dash is x sine x to the power 2, integration gives me minus half cos x to the power 2. And your u is x to the power n minus 3. So u dash, when you differentiate, n minus 3 times x to the power n minus 4. Do you agree? Okay, so then let's substitute the values now. half times root means the power half. So shall I write pi over 2 to the power n minus 1 over 2? Is that how they have given it in the show that? Yeah, n minus 1 over 2. Because a root means the power half. So half into n minus 1 is n minus 1 divided by 2. Sine pi over 2 is directly 1. So that's directly 1. Minus 0 is not required. Minus half times n minus 1. Open a large bracket. Shall we input uv minus vu dash? So u v minus integration v u dash. U dash is the differentiation of x to the power n minus 3. And close the large bracket. Half times pi over 2 to the power n minus 1 over 2 minus half. Shall I open the bracket? So here I get minus half into minus is plus half plus 1 over 4. Shall I directly do it? Plus 1 over 4 n minus 1 times. Yeah, okay. So you want me to first put the limits here and then we'll open the bracket? Okay. Let me go like that. So I'll keep the large bracket here. Minus half times n minus 1. Okay, so this is minus half x to the power n minus 3 cos x to the power 2. Your limits are from where to where? 0 to root pi over 2, right? Am I correct? Yeah. And here minus minus becomes a plus. You can bring the half and n minus 3 out, which gives me x to the power n minus 4 cos x to the power 2 dx. Are you with me? Okay, so then who is x to the power n minus 4 cos x to the power 2? So you can see here we have x to the power n cos x to the power 2. This is in. So cos x to the power n minus 4 means it's I n minus 4, which is exactly what we have in our show that. Okay, so this is directly, this is I n minus 4. Okay, right. Then let's input the values now and let's substitute. So half times pi over 2 to the power n minus 1 over 2 minus half times n minus 1 minus half times when you input root pi over 2, what happens? Okay, so especially the cos pi over 2 is 0, right? So then do you agree if I just directly put a 0 here? Because here root pi over 2 to the power n minus 3 into cos root pi over 2 square is pi over 2. Cos pi over 0. Minus again when you put 0 for x in here, this x here, cos 0 is a 1, but here x becomes a 0. 0 into 1 is 0. That whole bracket is a 0. So I'm only remaining with half n minus 3. This is I n minus 4. Yeah, going in this approach is a lot easier and time saving. So half times pi over 2 to the power n minus 1. Now this part is completely gone. Minus half into plus is minus 1 over 4 n minus 1 n minus 3 I n minus 4. Is this to show that? Half, yeah, 1 over 4 n minus 1 n minus 3 I n minus 4. Yes, so as you can see, this is our 6 mark show that. Okay. So moving on to part B, hence determine the exact value of I5, giving your answer in its simplest form. So let's get the value of I5. So you go to the equation, replace n with 5. So I5 equals half pi over 2 to the power 5 minus 1 is 4. 4 divided by 2 is 2. Are you with me? Minus 1 over 4. What is it? 5 minus 1 is 4. 5 minus 3 is 2 into I5 minus 4 is I1. So as you can see this, now you can see we need the I1 value. However, this reduction formula only holds true for what? N values greater than or equal 5. So if I want to find I1, should I go back to the reduction formula again? No, to find I1, we'll have to go work on it manually. Are you with me? So we'll work on I1 manually. Go to the equation. I1 is integration from 0 to root pi over 2 x to the power 1 cos x square. So I1 is, what do we get here? X times cos x square. So this integration, we just had it right. Yeah. X cos x square, which we got earlier here. Integration of x cos x square is half sin x square. Can you see? Shall I directly put? This is half sin x square, and your integration limits are from 0 to root pi over 2. So half sine pi over 2 minus half sine 0. Sine pi over 2 is 1, right? So sine 0 is 0, which means I just get half. Okay, so we have everything ready now. Substitute back to the equation. I5 equals half into, shall I write pi over, yeah, it's pi over 2 square. 1 over 4 and 4 cancels. It's 2 into I1 is a half. So this is a half into pi square over 4. 2 into half is 1. So I end up getting here pi square over 8 minus 1. This is okay? Or you can make the common denominator pi square minus 8, the whole thing divide by 8. Or pi square over 8 minus 1 is more than enough. Do they give us any specific format? Hence determine the value of I5, giving your answer in its simplest form. So this is the simplest form. Okay? Okay, so let's move on to question number 7. A hyperbola H. A hyperbola H has equation x square over a square minus y square over 25 equal 1, where a is the positive constant. The eccentricity of H is E. Determine an expression for E square in terms of A. So now this eccentricity formula for hyperbola and then for ellipse, it's all given in your formula book also. Am I correct? Can I know the eccentricity formula for the hyperbola? B square equal A square E square minus 1. So here this is the A square is unknown, B square is 25, right? Because this is the B square value. Are you with me? B square is the 25. So let's input 25 equal A square times E square minus 1. Are you with me? They're asking you to subject E square, determine an expression for E square. So 25 over A square equal E square minus 1, which gives you E square equals 25 over A square plus 1. Are you with me? Okay, it's 25 over A square plus 1. No, they want you to get the expression for E square. So then you do not have to square root it. Just leave your answer like this and it's enough. And then part B, the line L is the directrix of H for which X is greater than 0. Okay, the points A and A dash are the points of intersection of L with the asymptotes of H. Okay, do you know what's happening here? You have your hyperbola and then what's it? They say here the points A and A dash are the points of intersection of L. L is the directrix and the asymptotes. Okay, so first let's get the directrix. What are the equations of the directrix equations in a hyperbola? X equals plus or minus A over E, right? So these are the equations for the directrix equations of a hyperbola. And what about the asymptote equations in a hyperbola? These are all theories given in your given in the second chapter, right? So what are the asymptote equations given to you? Y equals, the asymptotes are given to you. Okay, so they say here the line, yeah. So now I wrote the asymptotic equation y equal plus or minus b over x. Now what do they say here? The line L is the directrix of h for which x is greater than 0. So which directrix equation do I need? I only need the positive one. Okay, so then they say this directrix, what is this? The points A and A dash are the points of intersection of this line L with the asymptotes. So both of these asymptotes, so this it's the A and A dash are the place where this directrix meets with these asymptotes determined in terms of the length of the line segment A dash. So if you want to kind of have a small visual representation of what's going on here, okay, so you can draw. See, now you know this is how the asymptote, this is how the hyperbola equation goes, right? The directrix is that we don't need the negative directrix, we only need the positive one. So I'll just draw the positive one here. So can you see I'm drawing this x equal plus a over e. Are you with me? And then asymptotes normally you draw like this, right? So this is one asymptote. And this is the other asymptote. So this is the y equal plus b over x. The other one is y equals minus b over x. So then they say the place where it cuts the line, the directrix and the asymptote meets at the point what? A and A dash. So one point, can you see A here? The place where they meet A and A dash. So they are asking you to get the what? They are asking you to get the distance, find in terms of the length of the line segment A dash. Okay. The first thing is directrix equation x equal A over E. A is unknown. E is also, we have an equation in terms of A and E. Okay. What about the asymptote equation? Y equal plus or minus. B value is known, right? B square is 25, which means B is 5 over A x. Are you with me? So what we'll do here is, in this case, let's solve the two equations simultaneously. X equal A over E. Okay, so shall we solve it? Shall we input the value of x? So I'll input the value of x here. Y equals plus or minus 5 over A times x is A over E. A cancels and then you get y equals plus or minus 5 over E. So plus or minus 5 over E in the sense one coordinate will give the y coordinate of A, the other one should give the y coordinate of A dash. So y coordinate of A, you can obviously see it should be the plus 5 over E. The y coordinate of A dash should be minus 5 over E. So what do you think is the distance? A dash y distance. A dash length. No, so you can see it's directly a vertical height, right? A to A dash, directly a vertical height. And you can see here the A y coordinate is 5 over E. The A dash y coordinate is minus 5 over E. So you just need to add the two y lengths. Just add the two y lengths. 5 over E plus 5 over E gives you 10 over E. Okay? Okay, and then the next part, the point F is the focus on the focus of hyperbola for which x is, what is this? Less than 0. So now they are talking about the focus where the x coordinate is negative. Given that the triangle, area of the triangle A dash. Now can you see how important it is to actually have a good diagram here? Okay, it gives you an idea of what's going on. Okay, so they say here the coordinates of given that the area of triangle A dash is 164 over 3, show that A is a solution of the equation. Okay, so shall we try? First thing is, what do we need to do? Get the coordinates of the focus. Can I know the coordinates of the focus of the hyperbola? Focus coordinates is, yeah, x equals, can I know the value? AE plus or minus AE comma 0. Now they tell us here x is negative, which means your f coordinate should be minus AE comma 0. Are you guys with me? Okay, so let's say this is the focus f. Can you see focus f is minus AE comma 0. Minus AE is this length. Are you guys with me? Focus f is inside. Okay, now, okay, so let me draw. They are asking you to do what? They are asking you to get the given that. So they've given that the area of triangle AFA dash is 164/3. Show that A is a solution of this particular equation. Okay. So shall we try to get the area of this equation, area of this particular triangle? So how do I get the area? Half into base into height. Can I know what is the base and what is the height? Base is the A dash distance, which is 10/E, what we found in the part B. Height is this distance, right? So I think you can see this small distance is the positive distance is A/E, and for that you have to add the distance minus A. We don't take the negative, we need the distance. Are you with me? So it's not the minus AE, I need the distance. So this is AE plus A/E. Can you see? This positive distance plus the negative distance, remove the negative. Because end of the day, I just want the distance. The x coordinate gives the length here. So then the height is A/E and you add the AE. Do not take the negative mark because we need to get the length. Simply the length. And this area is equal to what? They say the area of the triangle is equal to 164/3. Okay, then let's try to get the show that. So in the show that, you can see the show that is entirely made up of only with A terms. But I think you can see in our equation, it's made up of both A and E. So we need to get rid of the E. The show that has A. We need to get rid of the E. Okay, so let's first simplify what we can simplify here. 164. Shall I take the, 2 and 10 we can cut. So I end up getting here what? 164/3. Yeah, we can multiply. Shall we multiply with 5/E? 5/E into A/E, I get 5A/E square. And then 5/E into A/E, E to E cancels, plus 5A. Do you agree with what I did here? Okay, and then you can see I have a E square here. Okay, and then I think you can see here for E square, we already have an expression. Can you see? E square is 25/A square plus 1. Shall we try to get this E square for subject as 164/3 minus 5A is 5A/E square. Are you guys with me? Okay, then shall we simplify? Just take the common denominator with 3. This is, I'll multiply the whole thing with 3. I get here 164 minus 5 times 3 is 15A. 164, 5 times 3, 15A. This is 15A/E square. Are you guys with me? Sorry, this should be over 3. Oh no, we are multiplying by 3. We multiplied with 3. Okay, and then I get E square equals 15A/164 minus 15A. Are you with me? E square goes up, 164 minus 15A comes down. Now substitute E square. E square is 25 over, from 1 when you substitute, E square is 25/A square plus 1. 15A, 164 minus 15A. Are you guys with me? Let's now multiply and get the show that. I'll take the common denominator with A square on this side. Are you all with me? 15A times Okay, so now it's time to multiply. $25 plus a square into 164 minus 15a square. 15a times a square. Okay, expand the bracket, simplify. Okay, can you all multiply out 25 into 164? 4,100. 25 into minus 15a square minus 375 a square. A square into 164 is yeah, this is 164 minus 15a. Yeah. Okay, so I made a mistake. This should be 164 minus 15a. So then this is 25 into 164, 4,100. 25 into 15 is 375a. A square into 164, 164 a square. 15a into a square is minus 15a cube equals here also 15a cube. So 15a cube will cancel out, right? Sorry, it adds together. And then what's to show that? Yeah. So take everything to the other side. 0 equals 15a cube minus 15a cube is adding off. So you get 30a cube minus 164a square plus 375 when I take it here and minus 4,100, and this is the show that. Can you see? So A is the solution of this equation. Is clear? Then the last part they say, hence using algebra and making your reasoning clear, show that the only possible value of A is 20 over 3. Okay, so you have to show that the only possible value of A is 20 over 3, which means they have given you one solution. Okay, so you need to kind of like factorize out and get the, now it's a cubic equation. So if the answer for A is 20 over 3, what's the factor? You get the factor 3a minus 20. So your factor is 3a minus 20. Now you need to get the remaining quadratic factor. How do we get the remaining quadratic factor? You can divide and take part D, right? Yeah. And then minus 4,100. So we'll divide this. Divide this by, you understood how I got 3a minus 20? Because they had given us a is 20 over 3, which means 3a minus 20 is the factor. Shall we quickly divide? 30a cube divided by 3a is 10a square. Multiply 10a square with 3a. You get 30a cube minus 200a square. When you subtract 0, minus 164 minus, right? You're subtracting. When you subtract minus 64 plus 200 is plus 36 a square. And then you can take these terms down, plus 375a minus 4,100. Then 3a divided by 36a square is plus 12a. Multiply the term again with 12a. 12a into 3a is 36a square. 12a into minus 20 is minus 240a. Do you agree? Subtract 36a square minus 36a square is 0, plus 375 minus is plus. Plus 240 is how much? 615. 615a minus 4,100. Agreed? Okay, then 615a divided by 3a. 615 divided by 3 is 615 divided by 3 is 205. A will cancel out. So 205 into 3a is 615a. 205 into minus 20 is 4,100. Subtract and you get the perfect answer 0 because it's a factor. So which means you realize what are your factors? 30a cube. Okay, 30a cube. Okay, so 30a cube minus 164a square plus 375a minus 4100 is 3a minus 20 times 10a square plus 12a plus 205. Now what do you need to show? You need to show that there is only this 3a my a equal 20 over 3 is the only possible root. So you have to show that this particular quadratic equation has no other root. So what are the possible ways of doing that? You can use a quadratic formula and say it doesn't come. You can either maybe show the discriminant and say that if the discriminant is negative, there are no other roots. There are no roots. So we'll take the quadratic factor. Ten a square plus 12a plus 205. So yeah, b square minus 4ac is 12 square minus 4 into a is 10. 205, how much is it? Minus 8056. Okay, is that correct? Check and see. 12 square minus 4 into a is 10 into c is 205. So which is less than 0. Therefore, there are no other roots of the equation. Therefore, what does it mean? Therefore, a equals 20 over 3 is the only possible answer. It's the only possible value. Can you see how we give the argument? Is this clear? Okay. Okay. Okay, so now we'll move on to question number 8 in the October 2021 F3 paper. Okay, so they say y equal r cos 2 root x, determine dy by dx. Okay, so you're supposed to differentiate r cos 2 root x. So what's the rule that we use? So these are rules you have learned in the textbook. I have given the generalized format. So r cos fx, I have given the generalized format here. R cos fx is minus 1 over root 1 minus fx square into f dash x. Okay, so when we differentiate here, y equals r cos 2 root x, I end up getting dy by dx equals minus 1 over the square root of 1 minus, okay, so fx, what's the fx here? The function of x is 2 root x. So what happens when you square it? 2 root x square is 4x, right? So into, you have to now differentiate the 2 root x. So 2 root x differentiation is 2 times root x means x to the power half. Differentiation of x to the power half is half x to the power minus half. Are you with me? So the 2 and half cancels out. I end up getting dy by dx equals minus x to the power minus half, right? Minus 1. So x to the power minus half, shall I take it down as a root x? X to the power minus half, when you bring it down, it's x to the power plus half, which means it's a root x. And then also you have root 1 minus 4x. Do you agree with me? So this is the dy by dx. Or if you want, you could have kept it up as x to the power minus half. I mean, you could have kept the root x up as x to the power minus half. That is also okay. Okay, so any of these, any answer format is okay. Or you could have kept your answer as minus x to the power minus half over root 1 minus 4. So any of these equivalent answers are okay. Okay, so another person could actually multiply the x in, right? because both of them are roots, you can multiply, right? And you could have put the x inside and said inside a single root. Another person could say inside a single root minus 1 over the root x goes inside and becomes a single surd x minus 4x square. So all of these answers are correct. Okay, all of these are okay, all of these are acceptable. Okay, so I will go with the first one. And then they say part B, show that the integration of y with respect to x. Okay, how do we integrate? How do we integrate y in the sense you're supposed to integrate r cos 2 root x. So you can very clearly see we know how to what? We know how to differentiate it. So how do we integrate? How do we integrate y equal r cos 2 root x? So this is something specifically taught in the F3 book. You learn, you have a special on the integration. You learn this very specifically. So in that you learn, we do this by using what? Parts by integration. We do this by using integration by parts. So what do we choose for the u and what do we choose for the dv by dx? U is 1, sorry, the dv by dx is 1 because you know how to differentiate r cos 2 root x, isn't it? So r cos 2 root x is the u and this is the v dash or the dv by dx. So then let's write down. So what happens here? Your u is r cos 2 root x, which means your du by dx or your u dash. Your u dash is, we just found it, right? We just found it. Okay, r cos 2 root x differentiation is minus 1 over root x times root 1 minus 4x. I will go with this format because when I look at the show that, can you see when I look at the show that it shows root 1 minus 4x. Now I need to get this show that. Okay, so I can see in the show that root 1 minus 4x is like specifically separately staying. So I chose to go with this format out of all the three. Okay, you can go with either the first or the second. Any of these two should be okay. And then the v dash is 1. So v dash is 1. So v dash to v, we integrate. When you integrate 1, what do we get? We get x. Okay, so r cos 2 root x. So what's the rule? uv dash, when you use integration by part, it's uv minus integration vu dash, right? So this is the parts by integration rule. Okay, so you don't need to write that. I just wrote it as a reminder. Let's input the values u. So u is r cos 2 root x, v is x. Do you agree with me? R cos 2 root x into x, uv minus integration v is x into u dash is minus 1 over root x times root 1 minus 4x. Do you agree with me? So when I rearrange, I get here x times r cos 2 root x minus the minus mark comes out, it becomes plus over integration. Now you can see the integration mark is there in the show that. Can you see I'm getting parts of the show that? So how do we get this show that? Now you have x on top and a root x at the bottom. So do you see x over root x to the power 1 divided by x to the power half, x to the power 1 minus x to the power half is actually x to the power half, root x on at the top. Do you see what I'm saying here? I'm taking these two terms. I'm taking these two terms and simplifying to give it as a single term. X to the power 1, x to the power half. So x to the power 1 minus half is x to the power half on the numerator. Is this clear? Okay. So that thereby I'm getting the show that. Can you see part B show that for 2 marks? Okay. Is this clear? Okay. So I'll move on to part C. They say use the substitution root x equal half cos theta to show that the integration of root x over root 1 minus 4x is equal to this. Okay. So we are supposed to integrate this part. Okay. So let's try this integration part C. They're asking you to use a substitution. Okay. So you're supposed to You're supposed to integrate root x round 1 minus 4x. Okay, so what's the substitution? You're supposed to use root x equals to half cos theta. Is that correct? Okay, so shall we first, whenever they ask you to substitute, what's the first thing to do? You must differentiate the given substitution. Okay, let's differentiate root x and differentiate. It's half x to the power minus half. Do you agree? Half x to the power minus half. Okay, and then half times cost differentiation is minus sine theta into, because it's theta, we do with respect to x, d theta by dx. So you do realize I'm getting a substitution here for what? For this dx. Shall we get the substitution for dx? The half and half cancel. Shall I remove the half? And then I get here 1 over root x equals minus sine theta times d theta by dx. So I'll bring the dx on top here and I get minus root x sine theta d theta. Do you agree with my working? Dx comes here minus the root x comes here. Okay, so now I have the substitution ready for dx. I also need to find the new limits. Okay, because these are x limits. Since I'm converting theta, I need to get the theta limits. So what are the theta limits? So we have here our first x limit is 1 over 8. How do you make it theta? So the substitution is root x equals half cos theta. So root x means it's root 1 over 8, right? X is 1 over 8 equals half cos theta. Can you all simplify? What do I get? Root of 1 over 8 is root 2 over 4 equals half cos 2 theta, which gives me the half and 4 will cancel out. Okay. So you get root 2 over 2 equal cos theta. So cos inverse of root 2 over 2 in radian mode, it gives you pi over 4. Okay, and that's the first limit. The other limit, that's the upper limit. Okay, this is the upper limit. Lower limit is x0. So root x equals half cos theta. When you replace x with 0, half into 0 is 0 equal cos theta. Cos inverse of 0 is pi over 2. So basically your lower limit is going to be pi over 2. Okay, lower limit is pi over 2. Shall we substitute everything into the sum now? Okay, so let's substitute everything. What's the sum? So coming back to the sum, it's root 0 to 1 over 8, root x over root 1 minus 4x dx. This is what we are supposed to integrate. So let's substitute the limit. 0 becomes pi over 2. The upper limit 1 over 8 becomes pi over 4. Replace 0 is pi over 2. It's 1 over 8 is pi over 4. And then immediately I will not change the inside because the successful integration by substitution. I mean, when you do a substitution, you have to completely convert everything to the theta variable. So I will not immediately touch this. Let's first keep this. So substitute the dx. So what is dx? We found dx substitution. Dx is minus root x sine theta. Minus root x sine theta d theta. So you can see here root x gives you a complete x. I'll bring the minus mark out. X times sine theta d theta divided by root 1 minus 4x. Okay, now it's time to replace the x. So what do we know? We have the substitution root x is half cos theta. Okay, so if root x is half cos theta, it means x is, you have to square both sides. So when you square, it's 1 over 4 cos square theta. Do you agree? Root x is half cos theta. So x is 1 over 4 cos square theta. Let's replace. Minus x is 1 over 4 times cos square theta into sine theta. So this is the replacement. Okay, so this is me replacing the x here. Divide by root 1 minus 4 times x is 1 over 4 cos square theta. Are you with me? So here I've replaced this x down here. Okay, so now let's simplify. The 1 over 4 at the top, I'll bring it out minus the 1 over 4 in the numerator, I'll take it out. So I get cos square theta sine theta over the 4 and 4 cancels here. 1 minus cos square is sine square. Root of sine square is sine theta. Do you agree with me? 1 minus cos square is sine square. Square root of sine square is just simply sine theta. Okay. And then when the sine theta cancels, you end up getting here. Is that the show that? Yes. So we have the show that almost there is extra negative sign. So why do we get the extra negative sign? What are the limits, by the way? So our limits are pi over 2 to pi over 4, right? Pi over 2 to pi over 4. Yes. So then when you have this now, you can see in the show that there is no negative sign. Okay. So then what you can do is to get rid of the negative sign. You know, when you switch the limits, we can generate another negative sign and cancel this out. You're aware of this. This is something you know in P2 also. So I will switch the limits and negative becomes positive. So I'm switching the limits. Clearly pi over 4 comes down and pi over 2 goes up. And so when I switch the limits, the negative mark outside is used, and thereby when I switch the limits, I get the show that. So this is the show that we were supposed to get. Am I correct? Yes. So A and B. So we have the A and B values. Okay, then part D thereafter, hence determine the exact value of arc cos 2 root x. So you are supposed to hence determine the exact value of the integration of arc cos 2 root x with the limit 0 to 1 over 8. So I think you can see we were halfway through the integration of arc cos 2 root x in part B. You notice integration, this y was arc cos 2 root x, isn't it? So we were integrating this and we came to this point. So we had we came to this point and we stopped. So you can see now this integration answer we came to part B, part C. It was 1 over 4 cos square theta. So I think it's very clear. It's really you all know, you're quite clear. I hope you all remember how to integrate cos square. So this is something you'll do in P3. Integration of cos square by using what? The cos double angle formula. You can integrate cos square. Okay. So let's integrate cos square, and all we have to do is to input the value here and get the final answer. Okay, shall we? So I'll move on to part B over here. Okay, shall we first finish integrating the integrating this part? Yeah. Okay, so what happens here? So I will finish integrating 0 to 1 over 8 root x over root 1 minus 4x with respect to x. We got this answer as 1 over 4 times. Limits were from pi over 4 to pi over 2 cos square theta d theta. Okay, so let's substitute what is cos square theta. We know cos 2 theta is 2 cos square theta minus 1. If you remember this, you can directly use cos square theta is cos 2 theta plus 1 whole thing divided by 2, which means I can take a half out. Do you agree? So 1 over 4 into 1 over 2, 1 over 8, pi over 4 to pi over 2, cos square theta is cos 2 theta plus 1. So time to integrate. What happens when you integrate cos? Cos integration is sine. Sine 2 theta, and what about the 2? Because it's 2, it should be half sine 2 theta plus integration of 1 is theta with respect to theta. So limits are from pi over 4 to pi over 2. Let's input the limits. 1 over 8 into half. Yeah. Sine 2 times pi over 2. 2 times pi over 2 is sine pi plus pi over 2. So first limit minus the second limit, pi over 4, half sine pi over 2 plus pi over 4. Sine pi is 0. So I get here 1 over 8 times pi over 2 minus half sine pi over 2. Sine pi over 2 is 1, right? So this ends up giving you minus half when you open the bracket and minus pi over 4. So pi over 2 minus pi over 4 when you simplify. Pi over 2 minus pi over 4 is pi over 4 minus half. Do you agree with me? Okay, so that is the answer only for this part. So we also have to go with the other part. So the full answer, and we have to substitute the, we have to get the complete answer. Okay, so coming back for integration of r cos 2 root x, what was the answer? Quoting back from part B, it was x r cos root x, x r cos 2 root x plus integration of root x over root 1 minus 4x. So your limits are now from where to where? 0 to 1 over 8. Are you with me? Yes. So this one, now this is the answer for, you can see now I have got the answer for this part. Okay, but for this part, we just integrate, we never put the limits. And you see, so we need to input the limits for this part because it's already integrated. Integration is over here. So this part was the one we had to continue the integration. So that is done in part D now. We have the complete answer. We can substitute that. This part we need to put the limit. So we need to put the original limit 0 to 1 over 8, right? Why? Because this is with respect to x. This is with respect to x. So we need to put the original x limit. Are you with me? We don't need to go for the theta limits. So when you input the x limits here, 1 over 8, arc cos means cos inverse, right? 2 into root 1 over 8. Okay, minus 0. So this is the, because it's x is 0, the whole thing is a 0. Plus this answer we just found. 1 over 8 times pi over 4 minus half. So can I know how much is arc cos 2 into 1 over root 8? Arc cos 2 into 1 over root 1 over 8 is pi over 4, which means it's arc cos root 2 over 2, right? This ends up giving you arc cos root 2 over 2. So it becomes pi over 4 plus 1 over 8 times pi over 4 minus half. Simplifying the last final few steps. 1 over 8 into pi over 4 is pi over 32 or 1 over 32 pi plus pi over 32 minus 1 over 16. Pi over 32 plus pi over 30, 1 over 32 plus 1 over 32, 1 over 16. So pi over 16 minus 1 over 16. So this is the final answer. Okay, so you can leave any equivalent answer. This is fine, but it should be an exact answer. Okay, you could take it to a common denominator of 16 and write pi minus 1 over 16 completely. So any equivalent answer for this is correct. Okay, is this clear? Okay, so this is the end of the October 2021 F3 paper.